Okay, we also have algebraic tests for determining whether a function is even or odd or neither. The first one is for even. A function is even if f of negative x is equal to f of x. Basically, this means that when you plug in negative x and you simplify the function, none of your signs change. A function is odd if f of negative x equals the opposite of f of x. In other words, when you plug in negative x and you simplify, all the signs change. You also have the situation where it's neither even or odd, and that is the case if when you plug in negative x, some of the signs change, but not all of them. So let's do a couple of examples. If you'll take a moment and copy this information down, and then we'll do a couple of examples to show you how this works. Okay, so we have this example. F of x is equal to 3x squared minus 9, and we want to know, is it even, odd, or neither? So the first thing we're going to do is we're going to replace our x with a negative x. So everywhere there's an x, we are going to plug in negative x. So take out your x. Everything else stays the same. We're taking out x, and we are replacing it with the opposite of x, or negative x. Next thing I'm going to do, once I've substituted in a negative x, is I'm going to simplify the resulting function. If I take negative x and I square it, that's the same as negative x times itself. Negative times a negative is a positive. So when I simplify it, I get 3x squared minus 9. So now we're going to ask ourselves the question, did any of the signs change? If your answer is yes, then it's not even. If your answer is no, none of the signs changed, then the answer for the question is that it would be even. So when I look at this, my original was 3x squared minus 9. My new one is 3x squared minus 9. So when I compare these two functions, they are exactly the same. No sign changes. Which means that my function is even, because I had no sign changes. Right? So take a moment, copy this down, and we'll start the next example. Okay, now we're ready for example 2. Again, we want to determine whether it's even, odd, or neither. So I have f of x equals 4x squared minus 3x. So again, step number 1, we're going to substitute negative x for each x. So everywhere there's an x, we're going to take it out and we're going to replace it with the opposite of x. So I take out my x, leave parentheses, everything else stays the same. Over here I have another x on the 3x term, take it out, leave some parentheses, and in those parentheses I'm going to plug in the opposite of x. Step number 2, simplify. Anytime you have negative x's in there, that's not simplified. So we need to simplify our situation. We need to square the negative x. Negative times a negative becomes a positive. So we have 4x squared. By the way, the 4 does not get squared. The 4 is not inside the parentheses, so the 4 stays 4. So we got 4x squared. Over here I have a minus 3 times a negative x. So that negative and that negative, minus times a minus, a negative times a negative becomes a positive. And that's a positive 3x. So now, once I've done that, I'm now going to check my signs. Okay? I want to know, did any of my signs change? So did any signs change? The answer is yes. If the answer is yes, from here to here. Did any of them change? The answer is yes. So this is not even. Okay, that's the first part of my answer. I know it's not even. As I'm looking at it again, second question, did all of my signs change? And the answer to that is no. The 4x squared is still 4x squared. That sign did not change. Negative 3 became positive 3. That one did change. So the first one didn't, the second one did. So since all the signs didn't change, it's not odd. Therefore, my answer is neither. This function is not even, it's not odd, it's neither. Take a moment to record in your notes. Okay, now for our third and final example, even, odd, or neither. Again, f of x is equal to x cubed take away x. So I want to know if it's even, odd, or neither. So my first step, just like before, is we are going to substitute the opposite of x for each x. So we're going to come over here where it says x cubed, take out the x, put the cubed, hold it open with some parentheses, and then for the x over here we're going to leave it open with some parentheses, and in each one of those parentheses we're going to plug in the opposite of x, or negative x. Step number 2, just like before, we're going to simplify. We want to try to make this look a little simpler. So this time we've got negative x times negative x times negative x. You get 3 negatives being multiplied together. That gives you a negative. And x times x times x is x cubed. Even though it doesn't look a whole lot simpler, it is because the parentheses are gone. On the next one, we've got a minus times a negative. That makes a positive x. So now when I look at my original and I look at my new answer that has been simplified, I want to look at my signs. So first question, did all signs stay the same? Or you could ask the kind of the opposite of that, did any of the signs change? Did all the signs stay the same? No, they didn't. So it's not even. Next question. Helps if you can spell the word did. Did all signs change? This will answer the question about whether it is odd or not. If you look at the first one, we went from x cubed to negative x cubed, so this one changed. Negative x became positive x, so this one changed. So all of my signs changed. So Yes, which means that our answer is odd. X cubed take away x is an odd function. If you were to graph it, you would see that its graph would have origin symmetry. Alright, that's it for our notes today. We will see you in class tomorrow. Thank you. Bye-bye.